Okay, next question, number 42. This question is an optimization problem. A rectangle inscribed in a semicircle of radius 8 has one side lying on the diameter of the circle. So here we go. Here's the semicircle. It's got radius of 8. So here you go, radius of 8. And there's a rectangle that's inscribed in the semicircle. So inscribed means inside. Inscribed, inside. Circumscribed means outside. Has one side lying on the diameter of the circle. What's the maximum possible area of the rectangle? So looking for maximum possible area of the rectangle. So we're going to have to create an equation for the area of the rectangle, then take the derivative of that equation and set it equal to 0 to find the maximum. That's what we do with an optimization problem. So we'll say this is the base and this is the height. Well, the area of the rectangle equals base times height. Now I want to take the derivative of the area and set it equal to 0, but the thing is I can only have one variable in there if I want to take the derivative, so I have to find a way to either get rid of b or get rid of h in order to take this derivative. Well, fortunately I can do that. If I know that this whole thing is the base, then this right here is base over 2 from here to here. So if I take that triangle out and make it look something like this, I have b over 2, I have h, and I have the radius, which is 8. Okay, so now for the time being, I'm actually going to make this x, because it's just going to make my life easier. If this is x, then this whole thing here is b. So in other words, b equals 2x. Okay, it's just going to make my life easier. So I'm going to make that x, and that's h. So by Pythagorean theorem, this is a right triangle, so x squared plus h squared equals 8 squared, or 64. Therefore, solving for h equals the square root of 64 minus x squared. Okay, cool. So, if b equals 2x, and h equals radical 64 minus x squared, I can get this in terms of x. A equals 2x, b equals 2x times h is radical 64 minus x squared. Alright, cool. So that's the area, and now I have it in just one variable. Area equals 2x times the radical 64 minus x squared. So if I want to find the maximum of this, I just have to take the derivative of this. So I take the derivative of a with respect to x. I do that on both sides, d dx of both sides. And I get dA dx is going to equal, this is a product rule, so the derivative of the first, which is 2, times 64 minus x squared, is just radical 64 minus x squared, plus the first, which is 2x times the derivative of the second. This is 64 minus x squared to the 1/2, so it becomes 1/2 times 64 minus x squared to the 1/2 minus 1 is negative 1/2, times the derivative of the inside is negative 2x, right? Okay, cool. Well, just to make my life easier, I've got a 2 here and a 1/2, so that's good. So this equals 2 radical 64 minus x squared. This is plus, but there's a negative, so it's minus. And it's going to be 2x over the square root. So it's 2x over the square root of 64 minus x squared. Remember, it's optimization. Take the derivative of the area, set it equal to 0. So I'm going to set this equal to 0, and then I'll have to solve for x. So to solve for x, I'm just going to multiply this whole thing by the square root of 64 minus x squared. It's going to make my life easier. This then becomes, just starting over here, 0 equals 2 times the radical of this times another radical is just going to be 2 times 64 minus x squared minus, there's a radical on the bottom, radical on the top, so it's just minus 2x. Okay, that's cool. So now I just want to solve for x, so I'm going to simplify. This becomes 0 equals 2 times 64 is 128, minus 2 times x squared is negative 2x squared, minus 2x. Okay, I'm going to rearrange this. this becomes 0 equals negative 2x squared minus 2x plus 128. To solve for x, I'm just going to divide both sides by negative 2, and I get 0 equals x squared plus x minus 64. Okay, now at this point I can solve for x squared, and I want to try and figure out what I can do to solve for this. Excuse me, let me just think for a second here. Did I make a mistake? Oh, yes, I did make a mistake. There's an x here, I forgot about that. That should have been x squared. So I apologize for my mistake. This should have been x squared here. That should have been x squared. So this whole thing, I apologize for the mistake. You see this x, I forgot about that. So it's negative 2x times x is negative 2x squared. So this becomes 128 minus 2x squared equals 128 minus 4x squared.